All right, so we have percentage of an isotope given the mass, percentage of another isotope given its mass, percentage of another isotope given its mass, and percentage of another isotope given its mass. So we have four isotopes, and we are asked to running out of colors. Here we go. Purple. Calculate the average atomic mass and then identify the element. All right, so I'm going to just keep use the colors that I have on the screen, and we're going to use the mass of the first isotope times its percent abundance. We are going to add that to what's that? Mass of the second isotope times its relative abundance, and we're going to add that to the mass of the third isotope times its relative abundance, and we're going to add that to the fourth isotope, mass of the fourth times its percent abundance, and that's going to give us the atomic mass, and we'll use that to figure out what element it is. All right, let's just plug and play. No algebra, nothing. Just punch these numbers in your calculator. Just do it. 20. I may run out of space. These are a lot of digits, but I'm not going to write the unit. We'll do that at the end. Careful. I've seen this like every year. Students will just, for whatever reason, they'll say 1.4% and decimal form is 0.140. That's not true. That's 14%. Make sure you move that decimal over 2 spots. So 0.0140. Get that 0 looking like a 0. All right. See. Second isotope has a mass of 205.9745. Its relative abundance is, move that decimal over twice, 24.10% is 0.2410. Let's add that to the third isotope, which has a mass of 206. It's getting a little late. Gotta finish this up. 206.9759 times its relative abundance is in decimal form is 0.2210. Yeah, I'm gonna run out of space. Just gonna the mass of the fourth one is going to be 207.9766 times its relative abundance is 50. Oh, just change that to decimal form. Move that decimal over twice. 0.5240. And all of that's going to give us our answer. All right, let's get our calculator out. Looking good. 203.973 times 0.0140. I'm just going to write the sig figs. I'm going to write these separately so I can see the sig figs. So that's 3 sig figs times much more than 3. So I can only have 3 digits here. It's going to be the 2.86. 2.86. All right, in the end, I'll use the better calculation, better numbers from my calculator. I'm just doing this so I know how many placeholders I need in my final answer, because we're going to end up adding at the end of this after all this multiplication. All right, so don't clear your screen. 205.9745 times 0.2410. I'm adding that 0 because it's just going to show me my sig figs. But you don't have to do that. I recommend you do it though. Alright, so 4 sig figs times 7 sig figs. Your answer can only have 4. So it's going to be 49.64. 49.64. Alright, that's the second isotope. Alright, now let's go on to the third one. Don't clear your screen. 206.9759 times, I'm just going to look on my board here, it's 0.2210. Right, oh, that's from the word problem. Alright, so that's 4 sig figs times, again, 7. My answer can only have 4 significant figures. Is 45.74. 45.74. That's from this here. And then finally, don't clear your screen, 207.9766 times, where is that on the screen? 52.40% is 0.54. Oh, make a mistake going this 52.40. All right, so that's 4 significant figures times, again, 7. My answer can only have 4. See? So that's what I'm talking about. So it would have been hard to see all of this. 108.97, we're going to round that to 109.0. .0. All right, so look at these numbers. We're going to have to add them up. And when you're following sig fig rules for adding or subtracting, your answer can't have more precision than the least precise numbers. I'm just going to put these up just in order, line them up in by placeholder. So we got a 2.86 from there, and the 49, line up the ones, the tenths, the hundredths, that's good. 45, that's from there, by the way. And then I'm going to go here, 45.74, and then this one's going to limit our final answer. You can see it only has 1 decimal place. So, come on, where's my... Yeah. Alright, so let's punch these numbers in. There's my first number, plus my second number, plus my third number, plus my final isotope, equals 207.2. I can only have that 2. 207.2. 207.2. Can't have anything out here because this number there never knew that precision. So there's my final answer. There's my, oh, there's my average. Talking about 207.2. So we've done that. Now let's identify the element. Let me grab a periodic table. There's your answer.